This is exercise 3 of problem set 1. And now in this case, they're giving me this network over here, okay? This is the network that I have to work with. And as we can see, this is a disconnected network. It has two components, okay? This is the first component and, well, one component, and this is another component. So first of all, they tell me to calculate the adjacency matrix. So the adjacency matrix is really simple, okay? I just have to remember that I have to make a matrix which has many rows and columns as the number of nodes. In this case, we have the maximum, it goes from 1 to 8. So it has 8 rows and 8 columns. So I have to write here. Okay, so it's going to be, and now the first row is going to tell me what are the nodes that are connected to the first node. So I have 1, 2, and 1, 6, and 1, 8, and the other links are inexistent, okay, are non-existent. So in this case, I have, 0, 4, 1, 1. Now 1, 2 is a 1, 1, 3 is a 0, 1, 4 is a 0, 1, 5 is a 0, 1, 6 is a 1, 1, 7 is a 0, and 1, 8 is a 1. So this is the first line. Since this is an undirected network, then I have to write exactly the same row as a column, okay, because this is going to be a symmetric matrix, and a symmetric matrix has the first row is equal to the first column, the second row is equal to the second column, and so on. So this is going to be also the first row. Now, for the second row, I already have the first value, okay, the first value, which is the one that is giving me the information about this link. So node 2 is connected to node 1 and node 5, only to those nodes. So the rest is going to be 0, okay? So I'm going to have, this is 2, 2, 2, 3, 0, 2, 4, 0. Now 2, 5 is 1, 2, 6 is 0, 2, 7 is 0, and 2, 8 is 0. So this is the second row, and the second column is going to be exactly the same. I have 1, 0, and then 0, 0, 1, 0, 0, 0. So this is going to be the second column. Now for the third row, I have to focus now in node 3. Node 3 is only connected to node 4. So all the rest is going to be 0. So node 3 has no links to himself, but it's connected to node 1, to node 4. So I have a 1 there, and the rest is 0. Okay, and here exactly the same. I have 1 and the rest is 0, 0, 0, 0. Now for node 4, node 4 is connected to node 3, which I already have here, and also to node 7. So, and the rest are 0. So I have, this is a 0 for node 4, now 5, 6, 7, I have a 1, and now 8, I have a 0. And I have exactly the same here. So I have 0, 0, 1, and 0. Now, I have node 5. Node 5 is connected to nodes 2 and 6. Node 2 I have already here. Okay, so I have already written this link. So I have nodes 2 and 6, and the rest are 0. So I have for 5 I have a 0, and now a 1 for 6, 0 and 0 for 7 and 8. So I have a 1, a 0, and a 0. And I have left 6, 7, and 8. Now, number 6 is linked to 5 and 8, and the others are 0. So number 6, this is a 0 for the 6, and also to 1, but I have already this information here, okay? So 6 is connected to 1, 5, and 8, which is 1, 5, and now I have to write the link of 8, okay? And the same here, so I have a 0 and a 1. Now node 7 is only connected to node 4, which is also already here, okay? 1, 2, 3, 4, this is the fourth node. So the rest are all zeros. This is a 0, this is a 0, and this is another 0. And the last but not the least, node 8 is connected to node 1, which is already here, and also to node 6, which is already there. So this is all the information. This is already here. So I only have to write there a 0. So this is my adjacency matrix. That's it. Now, on the second, this second question in this exercise, they're asking me to relabel these nodes by components. So the idea is that to put, to name all these nodes from 0 to 5, and from 1 to 5, sorry, from 1 to 5, and to relabel all these nodes 6, 7, and 8. Okay, so that's what I'm going to do. My new network is going to be 1, 2, 3, 4, 5, and now 6, 7, and 8. This is the idea. So, and then I have to rewrite the adjacency matrix and see what's going on. So I'm going to call this new adjacency matrix A prime, and I'm going to do exactly the same. So the first row is going to be the labels of the nodes where 1 is connected to. So 1 is connected to nodes 2, 6, sorry, 4, sorry, 4 and 5. Okay, so I have 2, 4, and 5. So this has to be a 0, 1, 0, 2, 4, and 5. 1, 2, 3, 4, and 5. And the rest are zeros. 0, 0, and 0. Okay, and we have a total of 8 elements in this row. Okay, so 8 columns, everything's fine. Now, for the second row, now I have to focus, well, I'm going to write exactly as before. I'm going to write this column. Too close. Okay, yes. 1, then 0, 0, and 0. That's it. So now I have my bracket there. Okay, yes, I'm going to rewrite this as well. Well, more or less. So, second row. The second row is associated to this node, to node 2. So it's linked to nodes 1 and 3. So in this case, node 1 is already here and node 3 is this one, and the rest are zeros. And I'm going to write exactly the same here for 3, and the rest are zeros. 3, 4, 5. And now for node 3. Node 3 is connected to nodes 2 and 4. So node 3, I have a 0 here, and it's connected to 2, which is already here. Okay, this is it. And also to node 4. So for node 4, I have here a 1. 1, and then 5, 6, 7, and 8 are zeros. So here I have a 1, 0, 0, 0, and 0. Let's go for node 4. Node 4 is linked to nodes 3 and 5. So I have here 4 and also to 1. Yes, so I have here this 1 and the rest are zeros. 1 and the rest are zeros. I'm going to, don't know if this is a good idea, but I'm going to do it. Okay, so this is the diagonal. Okay, now I have for now number 5, node number 5, which is this one, is connected to nodes 1 and 4. Okay, 1 is already there and 4 is already there, and the rest are zeros. 0, 0, and 0. Now I have the other component, okay? And for the other component, I have nodes 6, 7, and 8. So nodes 6, 7, and 8 are going to be linked 6 to 7, 7 to 6 and 8 to 7. So 6 is going to be linked to 7, and that's all. 7 is linked to 6 and 8, and 8. And 8 is linked to 7, that's it. So this is going to be my new adjacency matrix. And this is important because let's have a look at this matrix, okay? As you can see, we have a lot of zeros here. All these elements are 0, and also all these elements are 0. Okay, this is a matrix by blocks, a block matrix, okay? That means that we have zeros, so A prime is equal to some adjacency matrix A1 here, this is all zeros, and some other adjacency matrix A2, okay? And this is going to be the adjacency matrix of this component, okay? So this is going to be this is going to have an adjacency matrix A1, and this is going to have another adjacency matrix which is A2, okay? That's it. So as you can see, we have a block matrix, and this is important because every time that we can relabel the nodes of a network, if I have something like this, that means that the network is disconnected. It has several components, okay? So that's the idea, that each of these components is going to be a block in this matrix. So this is a matrix and this is another matrix.